All right, let's look at the homework 9.3, problem number 9. All right, so this is a mixing problem. All right, so let's look at that. All right, so tank contains 7,000 liter of brine with 18 kilogram of dissolved salt. All right, so initially you have 7,000 liter and there are 18 kilogram of salt in there. So this is basically the initial condition. So I'm going to let S of t be the amount of salt in the tank after t minutes. All right, then initial condition would be S of 0. All right, that will be 18 kilograms. So S of 0 is going to be 18. All right, then we just have to come up with a differential equation. And remember that we look at the rate of change of the amount of salt with respect to time. All right, so all we need is the rate in. So we need to figure out the rate in, and then we subtract the rate out. All right, rate out. All right, so what will be rate in? Here's the clue. You can see that the pure water is entering the tank, which means that you're not really adding any salt to it. So the rate in is going to be actually 0. All right, but so you, since we keep on stirring the solution, so the concentration at time t would be, so here, so concentration would be, so there are S kilogram of salt, and the amount of solution is always 7,000 because the rate in and rate out is exactly the same. All right, then the rate at which it's going out of the tank would be at the 70 liters per minute. All right, so maybe I should put the minute here and minute here. All right, so the amount of salt that's going out would be, you just have to multiply, right? So you have S over 7,000, so that's the concentration, times the rate at which it's flowing out, so 70 liters per minute. So this is going to be kilogram per minute, right? So we can simplify this a bit. So you have a 70, and so it's going to be, so this cancel out, so you're going to be 100. So it's going to be S over 100. All right, so this is the initial value problem, so we can just solve this guy. All right, so first thing I would do is I'm going to divide through by, so since it's separable, divide through by S. So you're going to get the 1 over S ds over dt is equal to negative 1 over 100. Integrated with respect to t. So you have an integral sign and with respect to t. And we can cancel dt here and the dt there. All right, then antiderivative of 1 over s is natural log of absolute value of s is equal to antiderivative of negative 1 over 100 with respect to t would be negative t over 100 plus some constant. I'm going to use C1. All right, then to isolate s we can do raise e to the both sides. So e to the natural log of absolute value of s is equal to e to the negative t over 100 plus c1. But we can split it as e to the c1 times e to the negative t over 100. All right, then we can cancel e and the natural log. All right, so we have s, right? And in order to get rid of the absolute value sign, I'm going to put the plus or minus here just in case. Then you have e to the c1 and then e to the negative t over 100. All right, so there's no point of using a complicated expression for a number. I'm going to just call that c. So this is going to be simply c times e to the negative t over 100. All right, then we're going to use the initial value condition since we already used that. So I'm going to use this initial value condition. So s of 0 is equal to c times e to the e to the 0 is actually 1. So you're just going to get c. And we have to make sure that this is equal to 18 kilogram. Right? So it's 18. So we know that therefore we have, actually I use s, they're using y. So I got the s of t is equal to 18 e to the negative t over 100. Right? So I should have used y, but I used s, but this is 18 e to the negative t over 100. All right, so let's type it in. So it's 18 e to the negative t over 100. All right, so let's submit for testing. All right, it came back and we got part A correctly. All right, let's do part B. How much salt is in the tank after 10 minutes? All right, so we just have to evaluate this guy. So we want to find, so for part B, we just have to find s of 10 because it's after 10 minutes. So this is going to be 18 times e to the negative 10 over 100, which is going to be 18 e to the negative 0.1. Right? So let's see, you want 1 decimal place. So I'm going to just open up a calculator. So open up a calculator. All right, the value we want to come up with would be 18. So 18 times e to the, so second, so e to the negative 0.1. All right, so enter. All right, so it's a 16.3. So this is about 16.3. All right, so let's type it in, 16.3. All right, submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear. All right, so this was about 16.3. All right, that's it.